Hey everyone, and welcome to a new video. In this video we're going to talk about the physics system in Max, and we're going to create a little game which involves a rocket, a cannon, and a couple of platforms, a landing platform and a launch platform. So we start from the launch platform and we have to arrive all the way to the landing platform without hitting any object and without being hit by the cannon, which is actually pretty difficult. So it's kind of an unforgiving game, I have to say. So this will allow us to really understand how the physics system works, and we're going to see some rendering techniques and a lot of interesting stuff, I hope, while we build something like this. It's going to be a bit simpler than that, but in general, this is what we are aiming for. This game was heavily inspired by a Unity tutorial that I was following, so as kind of this Unity feeling, I guess, which I think it's kind of cool to be able to replicate something Unity-like in Max. Anyway, without any further ado, let's jump in and have fun. Okay, so let's start from scratch by creating a new patcher. First thing, I'll save it on the desktop. And then I will add a Jitter world, which we need to render our 3D visuals in Max. And I will give it a bunch of attributes. Like, for example, I want the window to be floating. I want the full scale anti-aliasing to be on. I want the size of the window when it's created to be small. And I want it to be disenabled by default. And maybe I also want to erase the color so that it's black on the background. Alright, there we got it. Okay, great. So this is already enabled. So if we create a JIT FPS GUI object, we should be able to see the frame rate. There it is. As you can see, is 60 frames per second. Let me actually desync it from the refresh rate of the screen and from the ProMotion of the MacBook. Cool. So first thing, let's actually create a skybox which will contain our 3D objects, our scene. So it will be kind of the background for our scene. And for that, I will use a GGL environment object to load the file for the skybox. And I want to use one that is built in inside Max. So we go in the file browser, look for whatever is an EXR file, see what we got here. Okay, we got the sunrise one, the photo studio, loft, all, and so on. So we could use one of those, like for example the photo studio loft all. We can copy file name, right click, copy file name, go into GGL environment, save file, and then copy that. So when we will create a GGL skybox, we will have these as our skybox. Now, if you want to use your own skybox, so an image that you can get from the internet, I got actually a bunch of resources on my website, so federicofoderaro.com. You can go into knowledge pot, and you can go into web resources, assets, and you can check a bunch of websites which have EXR images for the loading for free. So if we go into HDRIs, which is the format usually used to store skyboxes, we can check a bunch of those and just get the one we like. For example, let me just try to get one. So I would like this one, and I want to get it as 8K. I think it's going to be enough. It's already 272 mega. So it's still loading it. And the bigger it is, the better quality it's going to be. So you're not going to see the pixels in the skybox. Like here, we can see kind of the quality is not super high of this skybox. We can see kind of the pixels. We could check actually what's the actual resolution for that. Not the package manager, but the file browser. We can see that it's 5.7 mega, and strangely doesn't show me the size of this image. Let's see, if we try to import this in a JIT matrix, let's see which dimensions we got. So we can go like this, import movie, that. I just want to check what are the dimensions of this image. And apparently it's 2048 by 1024, so actually not even remotely 4K. So we want to have something 8K plus, I would say, to have a good quality skybox. Okay, cool. Let me close that. Go into Max, and now I take my file, I put it in the desktop, so it will be in the same folder as my patcher, and I will just rename this sky_box. And I will give it as a file name here, so skybox.exr. It will take a while to actually load this image inside the GGL environment. It will take a moment. And once it does, we shall see it appear here. At least take quite a while because it's an 8K file, which is definitely very heavy. And alright, there it is. Beautiful. If we want to kind of look around in the scene, we can create a camera, which we can then maneuverate with our keyboard. So GGL camera, and I'm going to give it tripod 1, because I don't want it to tilt. I would say look at 000 and lock look, so it will always look there. Lock look 1. Cool. Then I'm going to create the JIT anim driver as I always do in order to be able to control the camera with the keyboard. So UI listen, touch it to the GGL camera. And let's actually create also an anim reset message to reset the camera position. Cool. So now I can turn around with my keys, WASD and I can take a look at the scene. Very beautiful skybox. 8K, so pretty good quality. Cool. So let's start to build some 3D objects for our scene. So the first thing we need, I guess, is a floor. So I will create a GGL grid shape. And I will scale it. Actually, I will give it shape cube. And then I will scale it 10 on the x-axis, 0.3 or 4, whatever, on the y, and 10, and let's say 5 on the z-axis. Let's see what we got. Yes, that's what we got, some sort of floor. Now, I want to give it a material, so I'm going to give it a JIT-GL PBR object, attach it to it. And I will call this floor mat, something like that. And so I can go down in my GGL grid shape and give it a material. And give it the name of the material we just created, so floor mat. I could have just connected this with a cable, but in this way I can keep kind of materials and objects separated inside my patch, which could be kind of useful. Now I want to give it a different color, so I will go with matte diffuse. I want to make it sort of brownish, I guess. So I'm not really sure how this should look like. Something like that, actually. You know what, we can actually just right click here, check the attribute and modify it manually until we arrive to the color we want to have. Even reddish, it's okay actually. Something like that. Right, cool. And when we are satisfied, we just click here on these, we unlock the patch, we click here on this triangle, we're going to transform, change attributes to arguments, and there it is. It set the color of the matte diffuse to the one we were modifying manually. Cool. Without we having to copy manually those numbers inside the object. So, very nice. Now, what I want to do is to create little platform for where our rocket is going to be, is going to start. So let's create another GGL grid shape. And let's give it shape again cube. And I'm going to scale it this time as 2 on the y, 0.2, 2 on the x, 0.2 on the y, and 2 on the zeta. And there she is. It's a bit too thick. I will make it a bit smaller. Oh, and I forgot to write actually scale, right? So at the moment it's underneath our floor because it's positioned automatically at position 000. So I would like to actually move it around. So I'm going to right click, get the position attribute and see where I want to place it. So there she is, she comes up. So since this grid shape has a scale of 0.4 and our shape has a scale of 0.2, we basically want to place it as an y position at 0.6, which is the sum of the two scalings, so it will be exactly not overlapping with the shape, but just sitting nicely on top. And then I think I want to put it a bit more on the left, so I'm going to put it right there, and it's actually too much, very very big. It's too big. So I'm actually going to scale it a bit less on the X and Z axis. And then again, I want to put it at something like -6. Yeah, I guess this is good. -6 is going to be okay. 0.6 on the Y axis. Right, so it's now sitting nicely on the floor. And as we did for the material, I'm going to go here, transform, change attributes to arguments, so the position is now being set as an attribute. Cool. Let me create another material for the for this. This is going to be our ramp, so I'm going to call it ramp mat. And I'm going to give it another color. So first of all, I will assign it to our grid shape, so material ramp mat. And I want to change the color. So I want to make it sort of, let's make it red as it is in my example, in my demo. So let's make it something a bit more reddish. Yeah, something like that. Sounds okay. So let's click here, transform, change attributes to arguments. There she is. Cool. And let's now create our landing ramp. So again, I will just copy this grid shape. I will put it at the position of 6. And instead of material ramp mat, I will create a material called landing mat and assign it to this shape. So I copy this GGL PBR and say the name is going to be landing mat. And it's going to be something bluish. So again, right click, matte diffuse. I'm going to get some bluish color. Darker maybe, or some violish. This is also nice color. So I'm going to go here, change attributes to arguments, and there we go. Now maybe what we can do is to select all our materials, go in the inspector and change the color of their objects so that we know that these are all materials. I will just make them orange. Cool. And I can do the same for the grid shapes which represent our scene. I will make them maybe blue or something. Whatever, just to differentiate them from other objects. So we know this is our scene and these are our materials. Very nice. So now we want to start to create our rocket. So let's go here. Let's create a GGL grid shape, and our rocket is going to be a cylinder, because rockets are cylinders, right? So let's go here, give it a shape, cylinder. And as you can see, it's rotated on the wrong axis, because we want it to be vertical, right? So let's go and rotate X, Y, Z. 90 degrees on the X axis and 0 degrees on the other axis. Cool. Now let's actually scale it, let's actually position it first of all on the Y axis so we can see what's going on. Yeah, right? And let's now scale it so that is as actually 0.2 on the X axis, 0.6 maybe on the Y, 0.2 on the Z. Oh, but right, this was the scale before we rotated, so actually the Z-axis is now our Y, so we should do something like that. All right. Maybe a bit too tall even, so we can set it at 0.5. This looks about right. And let's create a new material and let's call this rocket body mat. Let's assign it to this grid shape. So material rocket body mat, and let's change the color. So I guess we want to have it like kind of whitish. I would like to have this beige or sort of white beige. Yeah, I guess I will go for white color, maybe a bit darker, like grayish, right? Here, transform, change attribute to arguments, and there we go. And now I want to add something to our rocket, like a little tip to make it more kind of rocket shaped. So I'm going to create another grid shape. This is going to be a cone, and the Y position of the tip of the cone, the tip of our rocket, it's going to be at 2.7 if we consider that we scale it as 0.2, 0.2, 0.5 on the z-axis, and as you can see, it's already rotated on correctly, just upside down. So we need to rotate it minus 90 degrees instead of 90 degrees. Oh, and the camera is a bit annoying because it's not really looking at my rocket, so I will go in the camera, change the look at attribute, and set it a bit higher because I actually want to look more at the rocket and not really at the position 0, 0, 0. Okay, it's a bit too tall, so I will squash a bit this tip, right, like this. So let's try to place it at 0.6. That's a bit too much because, as you can see, it went inside the body of the rocket. So let's say it's 0.65, and this looks perfect. Nice. That's our beautiful rocket. We should need some wings, but for the moment, let's not go into wings. Let's maybe create another material for the rocket point. I don't know, like tip. Rocket tip mat. And let's assign it to the tip. So this is rocket tip mat. And let's change it into something a bit different. So this will be a bit more interesting. We can maybe make it, we could make it red. It's kind of give the impression of a rocket, I will say. So let's go again here, transform, change attributes, and there we go. This nice rocket tip. Okay, very nice. Let's now place the rocket on top of our platform, because this is where we are going to start, on top of our ramp. So the ramp is at position -6. We are going to go with that, with the rocket. So -6 here, -6. But you know what? Since the rocket and the tip are going to be always attached together, we could actually create a JIT anim node for them, so they will always use the same transformation. So we don't have to change the position and the rotation for both independently, but this will be done through an anim node. So let's do that. Let's create a JIT anim node. And let's give it a name, let's call it rocket anim, right? And cool, this is going to be the attached to our body. And you know what, let's actually create a new anim node, JIT.anim. It's probably not necessary, but we'll make things a bit more clear. So we can give it a name and call it rocket body. And this is going to be attached to our body, and the rotation, position, and scale are all going to be now set inside the anim node and not anymore in the grid shape object. Cool. The effect will be the same because the grid shape is inheriting now the transformations from the anim body. And let's create another body. Now Max will probably complain that we already have a body called like that. Doesn't matter. Because we're going to change the name now into rocket, how did we call it? Tip. Okay, so let's keep calling it tip. And this is going to be connected here, but we have just to change the scale, position, and rotation. So instead of attaching them to the grid shape again, we attach them to the anim body. And both these anim nodes are going to be attached to this main anim node called rocket anim. Okay, so now if we try to rotate it, we should see the whole rocket rotate. Oh, but it's not rotating around its center axis, right? It's rotating around the center of the world, and that's because we are setting the position on the actual single nodes. Why should we actually set it on the main node here? So this is going to be our main position. And the position here should be relative to the main node. So for the tip, we want to say that 0.650. Exactly, because now the position is relative to the main node. So if now we rotate it exactly, they rotate all together, and they will inherit the rotation and the position from the main node. Okay, awesome. Now let's actually do like this. Let's set 0 here. Let's encapsulate that inside a sub-patcher. So this is going to be our rocket. Cool. And now what we want to do is to attach physics to our objects. Cool. So let's actually create a new JIT world, JIT physics world here, because we could use the one built in inside the JIT world, but we actually want to have an external one because it's going to be useful when we want to get the collisions, because at the moment we cannot get the collisions from the internal JIT world, physics world. So whatever I wrote, actually this is JIT phys world. Let me try to create a jit.gl phys draw. Okay, this will draw the world box related to this phys world. So let's actually give it a name to this phys world, because I'm not sure the phys draw is actually drawing this phys world, but I think it's actually drawing the one inside the JIT world, because inside the JIT world there is already a phys world that does already all the physics stuff, apart from collisions, which is exactly what we need. So let's give it a name to this phys world and call it, without much fantasy, phys world. Right. And this GL phys draw should have an attribute called world name, exactly. And we should set it to phys world. Okay, nice. So let's see. The world box disappeared here. And I think now we need to do a little trick, which is we need to set the world, the camera, and the phys world to draw to the same context in order to have this phys world be part of this JIT world, basically. We don't want to use anymore the one inside the JIT world, we want to use our own phys world. So we need to do this trick. So let's do like this, let's create a draw to. And let's, we can choose whatever name we want. So let's just call it global GTX or something, global context. Let's copy these. And we need to set these inside the camera. And we need to set these inside the JIT world. I think Max is crashing. Oh no, but it managed. Nice, because it had to redraw actually it actually needed to redraw the skybox. That's why it took so long. And I think it did the trick. So if we go inside the JIT phys world now and try to change the scale of the world box. Oh, and apparently I had to recreate the JIT phys draw in order to give it the actual, the correct phys world. So somehow it lost the world name attribute. Let's actually disable this by default. We don't want to draw the physics stuff. We just want to use it. So, and then we can choose to enable it in case we want to debug stuff. So we can create here a little toggle to enable it and disable it. Let me try to actually set the world box to 0 here. Yeah, exactly, because we don't really need the world box now. So I'm just gonna set it to 0. We don't really need the world box for our little rocket game here. Okay, cool. Now that we got all this stuff, we can go inside our rocket subpatcher and attach a physics body to our rocket. So because we want our rocket to interact with the physics system, because we want to maneuverate it according to kind of physics and not just by setting its position manually. So we're going to go in the rocket subpatcher, create a jit.phys.body, exactly. And we're going to give it a target name, and the target name is going to be the rocket anim node. And there it goes, just sinking toward the abyss, I guess, since we don't really have a world box, so it's just disappearing in the nothingness. Because now the physics is actually applied to the rocket. So it's starting to interact with gravity, which means it's going to fall down, like if gravity was pulling it toward the bottom of our world. Cool. In order to prevent this from happening, we want to assign some physics body also to our scene. So the object, the rocket, will fall on the floor instead of falling in the abyss. So this is the floor. We could actually give it a name just to remember us that this is the floor. Something like that. And want to attach it to a JIT phys body. right? And the scale in the same way the anim node sets the scale and the position for the objects, the body acts as well as some sort of anim node. So we need to set the scale not anymore on the grid shape, but on the PHYS body. And there it goes falling down. One thing is that we don't want this body, the floor, to interact with the physics. We don't want it to fall down, interact with gravity. So in order to avoid objects to interact with this physics system, but still be kind of rigid bodies, we can set the dynamics attribute to 0. And sorry, it's not called dynamics, it's called kinematic. So the kinematic attribute, we're going to set it to 0. Oh, sorry, we actually need to set it to 1, because kinematic 1 means it's not going to interact with the physics, it's just going to be kind of a cinematic object that can be moved only by animation set manually by us. Okay, it looks like the object is not really being scaled, so let's try to... Oh, right, because I didn't give it a shape, I think. It needs to know which shape we are working with in order to apply the correct scaling, otherwise by default it thinks it's a sphere. So nice, as you can see, we are now drawing with the PHYS draw, we are drawing the physics contours, and we can see that the shape and the actual PHYS body are the same. Cool, so this body being now kinematic should prevent the rocket from falling down. So let's send a message like position 0, no, actually -6 to, no, 1, 0, to our PHYS body to set the rocket back in place, and there it goes. It kind of jumped up from the floor, and there it is. If we give it this position a bit above the ramp, it will be there and then fall. It will appear a bit above the ramp and then just fall down on the ramp. There it goes. This is because it interacts with gravity. Let's delete this attribute inspector. Nice. I want to do the same thing for the ramp, actually, because at the moment the rocket is interacting with the floor only, not with the ramp. Although it looks like it's actually... Oh, and you know why it's actually not going down to inside the ramp? Because it's actually interacting with the floor, but since this thinks it's a sphere, the rigid body of the physics body of the... rocket, then it's actually interacting with the floor using this sphere shape, which is bigger than our actual rocket. So what we need to do is to start by giving it an initial position, I think, so -6 to 0. And we want to give it a shape, and we're not going to use a cylinder, or maybe yes. Is this a shape that we can choose? Let's see, because it's not like the shapes of the grid shape, is actually the shapes of the... It's actually some special shape only particular to the PHYS body. I think I will go with cube, actually, because it doesn't really matter if it's a cylinder or a cube. We just need to scale it down now. So on the x by 0.2, 0.5 on the y, 0.2 on the zeta. And that's all good, but our anim node got rescaled as well, because it's actually inheriting the scale of the main node, which in this case is this PHYS body, and was the same system that we used before, where we said we changed the... If we will change the position for this node, it will change the position also for the others node. This is working the same with the scale for the PHYS body, scaling the whole node. So what we need to do is to go here in our Jitter anim node and say inherit scale 0, and it should actually work. So why is this not working? No, this is not working because this is an anim node, this is a PHYS body. I don't think they work in the same way. So we should actually set the inherit scale 0 in the single nodes here. I'm pretty much sure this is what we need to do. So let's check. Seems like we lost the tip. Oh, and if we set the inherit scale to 0, we also need to change again its position, apparently. So it looks like we should set it to a position of 1.3, which will be then the main scale plus the scale of the tip, which makes sense. So Y position set to 1.3, right. Okay, so now the rocket is interacting with the floor, but we want actually it to stop on the ramp. The launch pad, actually this will be a better name, launch pad for that. So we want this to be stop on the launch pad. So we need to create another PHYS body for our ramp. So let's actually give it the name launch pad. Touch it a physics body, and of course we want to scale it as this and set this position. Kinematic is going to stay the same. Shape is again a cube. And there we go. If we visualize the physics stuff, we should now see that the rocket is standing on the ramp and not on the floor anymore. Nice. Of course, we want to do the same also for the landing pad. So let's do like this. We just need to move the position on the other side, the X position. So if we now check it out, right, we can see that the body has been applied to the landing pad as well. So let's give it actually a name also to the landing pad. Landing pad, that's what I wrote. So now let's start to animate our rocket. So what we need to do, what we want to do is to apply a force to this PHYS body. So the PHYS body has this attribute which is called force. So for example, if we apply a force of 0 on the x-axis, 10 on the y and 0 on the zeta, this rocket should start moving vertically. Very nice. And it's always being dragged down by the gravity. So if you will stop applying this force, then it will just fall down, right? So what we want to do is like to be able to apply the force when we press a key and then not apply the force anymore, when we're not pressing the key anymore. So let's create the key object and let's say cell 32, which is the space bar. So 32 is the space bar in ASCII code. I want to see when we do that, then apply a force of 20 on the y axis, for example. And when we do key up, so when we put our finger away from the space bar, then we want to apply a force of 0. So now if I press the space bar, exactly, the rocket goes up, and if I don't press the space bar, it will start to fall back down. Very nice, we have our first kind of interaction and rocket controlling system. And if I push the spacebar in middle air, it will still... Oh, and something happened, it's kind of rotated. But if I push the spacebar in middle air, it will apply the force again, like a propulsor, like a thruster, like a booster, some rocket engine thing. Okay, so this video is probably being already pretty long, so I want to stop it here, and I'm going to go on in the next one. In the next one, we're going to apply a rotation to the rocket and see how we can actually maneuver it to go also horizontally, to move horizontally. And then we're going to include the collisions so that we can have some game mechanics, like making some scores and winning the game or dying, something like that. And this we're all going to do probably in the next video. Cool. So thanks a lot for following. I hope this was useful. And if you like this video, a like to the video will really help the channel, and subscribe as well. I also got a Patreon channel where I will share the final patch that I showed you in the beginning, the rocket demo game. And I show a lot of other patches there on Patreon. So for a small fee, you can support the channel, get a ton of patches, and be a great Max programmer. Okay, thank you very much, and I will see you next time. Ciao.